So probability is a measure of the likelihood that an event will occur. And that measure happens between 0 and 1. This is very important. So at 0, that means it is impossible. 1 would be that it is certain or guaranteed. The book uses the word certain. I kind of like to use the word guarantee, but certain is the word we want to look at. And 1/2 is that the event is just as likely as unlikely to occur. Now to the left you've got unlikely, and the closer we get to 0, of course the less likely it is, and on the right of 1/2 it is likely, and of course the closer to 1 the more likely it is to occur. Now the way that we assign this measure is very simple. So probability equals the number of times or number of ways an event can occur divided by the total number of possible outcomes. And so we're going to do a couple of examples. Let's talk about rolling a die. Rolling a 6-sided die. Of course, die is short for, well, singular for dice. First of all, how many outcomes are there in rolling a 6-sided die? Well, there are 6 outcomes. 1, 2, 3, 4, 5, and 6. When we talk about performing an experiment in probability, we mean, in this case, rolling the die. So an experiment would be rolling it once. But we could also talk about what's the probability of getting a certain number, out of 6 rolls. But the experiment is what we actually do. Now, sample space is very important. It is a list of all the possible outcomes. Now, this is very similar to just listing the outcomes, but when they ask for sample space, you have to use the set brackets, and inside you list each outcome separated by a comma. And the order does not matter. Of course, with numbers, we tend to put them in chronological order. But when they want you to list the sample space, they have to be in this brackets. So now an event is one possible outcome or a group of possible outcomes. But we want to know how an event is different from an outcome. The way that I put it is that an event is a desired outcome. So we'll do an example in a minute, but the outcomes of rolling a die are 1, 2, 3, 4, 5, 6. The event would be, what's the probability of rolling an even? Well, now our desired outcomes, or the event, is 2, 4, and 6. And a simple event is when there's only one outcome, like what's the probability of rolling a 5? Whereas event can be a whole group. What's the probability of rolling an even? And so there you have 3 possible outcomes, whereas the probability of rolling a 5, there's only one possible outcome, the 5. So let's do a few of those. So the probability, let's talk about, of rolling an even number. Well, there are 3 possible even numbers on a die, 2, 4, and 6. So there are 3 out of the sample space, or the total possible outcomes, which there are 6. And we must always simplify our fractions. Now we can also write probability as a decimal or a percent. So we can write it as 1/2, or 0.5, or 50%. And if it doesn't specify, I tend to leave mine as fractions because I can quickly and easily turn them into decimals and percents. But if they ask for a decimal or percent, then you write it in that form. But all 3 are acceptable forms. Now the probability of rolling a 5, of course there's only one 5 on the die out of the 6 sides, and so it's 1/6. As a decimal, that's 0.16 repeated, so if we want to round it, that would be approximately 0.17, and as a percent, that would be 17%. Now, how about the probability of not rolling 5? Well, now it's 6 6, which is all of them, minus what 5 would be, which is 1/6. Or another way of looking at it is there are 5 numbers on the die that are not 5, so there's 5 out of 6 that would satisfy that. And again, this one would be 0.83 repeated, which would round to 0.83, which is 83%. Now don't be confused, this 5 had absolutely nothing to do with this 5. For instance, I could have just as easily said, what's the probability of not rolling 4? And the answer would be the same, because there are 5 numbers on the die that are not 4 out of the 6. Now these are called complementary events. Just the probability of 5 and the probability of not 5. Well, I changed it to the 4, but it should. We're talking about probability of 5 and the probability of not 5 would be complementary events. Complementary events are the events that make up the entire list of possible outcomes. So then what would be the complementary event to the probability of flipping a coin and getting a heads? Well, there's 2 ways of putting it. You could say probability of tails or probability of not heads. Either way is acceptable. It's just easier up here to say not 5 than to say the probability of 1, 2, 3, 4, and 6. Whereas down here it's just as easy to say probability of tails as it is to say probability of not heads. Now sometimes they might get a little tricky on this. They might ask you, what is the probability of rolling a 7 on the 6-sided die? Well, there are no 7s out of the 6 sides, so the probability is 0 or impossible. It's impossible to roll a 7. They might even ask you, what's the probability of rolling a number less than 7? Well, all 6 sides are less than 7, so 6 out of 6 equals 1, or certain. It's certain that you will roll a number less than 7. So don't let those trick you or fool you. They just want to see if you understand that there's no possibility or impossible or 100% or guaranteed or certain if you roll one less than 7. Now, when 2 events, or when an event is just as likely to occur as not, no, let's see. When we're talking about like the probability of rolling an even number on the cube and the probability of rolling an odd on the cube, since they are equal, these are both 3 out of 6 or 1/2. These are called equally likely, and that's another important term to know. This would also work if you had a sock drawer and you had, one yellow pair, one blue pair, one orange pair, one purple pair, one brown pair. Then what's the probability of drawing out any one of those? Well, they're all equally likely because each of them have a 1 in 5 chance of being drawn out of the sock drawer. So as long as all the probabilities are the same, or each of the probabilities is equal, then it's equally likely. And the last thing I want to mention is sometimes they will ask you for the complementary event to something like the probability of not rolling a 1. Well, remember, usually it's like, what's the probability of 1, and then the complementary event is not 1. Well, we don't want to say the probability of not 1, so then we would say the probability of a 1. And that's kind of logical, but I just wanted to go ahead and say it.